So here is problem 122, 285. Actually, there is no sister problem to this. I just wanted to quickly show you this problem. That's why I've written a lot of it down already. If you look on page 277, you can see that this transcendental figure E has been defined as this limit. This limit is n gets very large of 1 plus n all raised to the nth power. And you know, if you do that calculation for n large enough, you'll see that this is e to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. And of course, it's transcendental, so it's a number that has no repeating decimals on the backside. It just keeps going on and on. But here's the first 9 decimals. And here is an alternate way to calculate it. And I want to show it to you because it brings in this this definition of a factorial, where n factorial is equal to n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. Now, it has a couple of the definitions. 1 factorial, which I guess is defined in this case. N factorial is then just n is equal to 1, when n is equal to 1. And 0 factorial is also defined as 1. It's defined as 1. Doesn't make any sense from this formula. So for instance, 1 factorial is equal to 1. 2 factorial is equal to 2 times 1 is equal to 2. 3 factorial is equal to 3 times 2 times 1 is equal to 6. 4 factorial is equal to 4 times 3 times 2 times 1 is equal to 24, and so on. The factorial really increases pretty quickly. So all this problem asked you to do was go compute this formula for the case where n is 4, where the case is n is 6, for 8, and I think I chickened out and didn't do 10, and that's what you get down here. So if n is equal to 4, what you're doing is adding up 2 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial. There it is right there. 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. You add this all up, you get 2.708. So with just 4 terms, you're getting fairly close. You have the 2.7 already, and rather than the 18, you have an 8. So let's fix that. Let's try same thing. N is equal to 6, so you get 1/2, 1/6, 1/24. Good Lord, I hope I calculated that right. I'm pretty sure I did. N factorial when n is 5 is 25 times 4. 120 for n equals 6. N factorial is 720. Add them all up, and now with just 6 terms, we've got 2.718 versus 2.718. And if we go to 8 terms, I don't know if you can see this, but after 8 terms, we've got 2.71825. So we've got it correct to 4 decimal places after 8 terms. So you're going to find factorials will show up in probability. You're going to find that they show up in infinite sequences in series as well too. So just we'll let it go with that. Thanks. There you go.